Just a little disclaimer, CouchDB in itself has nothing to do with Ruby, and I'm not even a Ruby guy. I'm a PHP MySQL web development person, and so I might have the odd job presentation here, but I'm glad you all showed up, and there's a question? Yeah, I can do that, sorry. Maybe this, okay. So there's neat things you can do with Ruby and CouchDB, but there's not inherently, the topic of Ruby is not inherently embedded in CouchDB or somehow. So I hope you like the talk anyway. My name is Jan Lehnert. I'm from Germany, which you probably can tell from my accent. I'm a web developer, like I said, doing PHP MySQL. And I tend to keep an eye on emerging technology. That's how I came about CouchDB, because I thought that would be, well, if I had something like CouchDB, that would really, really make my life easy as a web developer. So that's how I got started with the project, and now I'm a contributor to the project and help to get the project along. That's me. The basic premise of my talk is CouchDB is an easy database, and it's easy on two accounts. The first one, it is easy to understand. There's not much magic going on. The concepts behind it are not that strange, or you can easily approach CouchDB. The second, even might be three things. The second one is the way to use CouchDB. The actual programming with CouchDB is relatively simple, so that new programmers who are not that experienced can easily get into the world of CouchDB. And the third one is, if you're into look over an application lifetime, the demands for a database usually change. In the beginning, it should be easy to program against it and use it. And when we have a mature application, you usually want your database to be easily maintainable. It should be scalable and all these things. And CouchDB makes that easy as well. So CouchDB is, from top to bottom, an easy database, sort of. And first off, CouchDB is not a relational database. So when people say database, they usually mean relational database. CouchDB is not a relational database. What CouchDB does is it takes, how do I get with that? What you usually do when you write an application is you have some sort of data model that you need to, where you go and take the data objects you have in your application and you split them up into different tables and design joins and queries and all this. And there's a whole lot of things going on before you actually start writing an application that is just the data storage layer. And in the end, you just want to store data and get it back somehow. And there needs to be, if you want to future-proof and all that, you need to be really careful to do things right from the beginning. And there's a whole lot of work to do. And CouchDB tries to make that easier. CouchDB has this, or introduces the concept of a document. And a document is like the things we have in the real world, a business card, a bill, or a receipt we get. And with these documents, they are structured. We have most of us have business cards, and there's a telephone field, an email field. So there's the same information on it, but there might be, I don't have a fax, you might have a fax. I don't have an office address on my business card, and you might have, and it's still, both things are business cards, but they are differently structured. And the same is with the receipts you get from restaurants or from where you buy things. For each shop you go to, it will look the same or similar, but for the different shops would have differently structured receipts or bills or whatever. And if you would want to build a financial overview application where you can analyze your spending or whatever, you will need to come up with a schema that accommodates all these different structures of all these documents there. And this is kind of hard. So CouchDB takes these concept of semi-structured data and lets you store just as is, as it occurs in the real world or in your application, and store that into CouchDB without the need to create a schema up front. There's no predefined structure. You just have a data object and store it into CouchDB. How does it technically work? CouchDB uses JSON. That's JavaScript object notation. It obviously comes from the JavaScript language, but has since evolved to be like available everywhere. And what it what it basically does is you have an object in your programming language, a native object with, I don't know, all the native types, like numbers, strings, arrays, or another object inside of there, and you can serialize that into a string representation of that object. And you do that and store this string representation, this JSON string, into CouchDB. Excuse me. Then you can get this string representation back and deserialize it back into a native object of your programming language. So you have a Ruby object, convert it into JSON, store it in CouchDB, and if you want to read that object again, you read the JSON out, convert it back to a Ruby object. Or if you do like I want to integrate different systems, you can deserialize it into a Python object or PHP or Java or any object in any language that supports JSON. And the nice thing about JSON, it maps naturally to all these native types, again, numbers and strings, dictionaries and arrays or lists that all programming languages share at some point. CouchDB used to use XML, and we found that XML is a bit too verbose. It does more things that we would need for CouchDB. So, we switched to JSON, which is a better fit for what CouchDB does. I hope you can see all that. This is an example JSON document, and it's basically just a list of keys and values. And values can be, again, either strings, numbers, there's an array there, and booleans. And this is very simple to understand what that is. It's easy to read and write and easy to parse computationally. So this is a very easy and simple thing. You notice two private properties, ID and rev. When you store something in CouchDB, you get back an ID. That's the identifier for that object. And if you give CouchDB that ID and ask for the data, it will give you the data you put in previously. So each document in a CouchDB database will have a unique ID that you can identify the data with. The revision thing is when you change things in a document, like you want to change the age, you don't tell CouchDB to increase the age by 1 or something like that, but you create in your replication a complete new document with the changed data, and then give that to CouchDB, and CouchDB saves this new document as the latest version, the newest revision or newest version of that document, and maintains the old one. So the revision ID there would change for different versions of a document, and you would be able to you make a change and decide that was a bad change. I want to undo it. You can ask for the previous revision or any revision and save that again as the latest revision. So there's a mini versioning control system embedded in that in CouchDB there. That's what I already said about JSON. The other thing is what I mentioned earlier with the application needing to spread out all the things into tables and reassemble all that. Again, usually happens in some sort of object relational mapper or database abstraction or something. And with this step of we take objects, serialize them, and store them, there's this messy thing that usually doesn't scale and has other problems. That makes our hair gray. Sorry. We just don't need that. We just do the serialization step, and we are done with the saving data. So that is, a great simplification of things. That is so far documents. One more thing, CouchDB documents can, email, can have attachments. You can put in binary data, images, PDFs, associate that with a document. So you can organize things nicely there. Okay, that's documents. The next topic. The way to talk to CouchDB is over HTTP. And we fully embraced this REST principle. That means everything in CouchDB, each document, is a resource. And we have the basic CRUD operations, create, read, update, delete, mapped onto the HTTP methods, put, delete, post, and the other one, get. And this is a very, very simple model. Everybody who knows HTTP or who works on the web directly understands this. You don't need to learn a new database driver or something. And every language or framework that supports HTTP already can talk to CouchDB. There's no, well, you don't need anything else there. And since everything that is kind of matters these days already does that, or does understand HTTP, well, you can use CouchDB from everywhere, from your browser, from the command line using curl, anything. That's, again, very simple, very easy to use. Everybody knows that. So there's no very steep learning curve going on. And there's a lot of tool support. We have like the scaling HTTP or analyzing, having proxies, caching, all that is solved for HTTP, and you can just use that with CouchDB, which is a great advantage. Okay. Yeah, I'll leave you with that. Now we have a dump object store. We can just throw things in, get a key, and ask for things that we saved under that key, and have the nice revision thing. But that's really a dump object store or data store. And the power of a database is usually that you can do calculations on a set of your data that you have in there, that you can manipulate them, sorting and all these. And that is what views are for. With views, you can define subsets of your data, get all the things that have like certain attributes. You can do collation. If you need a certain order of things in your application, you can have views do that. And you can do aggregation, that is make calculations based on the data that is in the documents, make counts, averages, everything you need there. And the way views are defined in CouchDB is you create a special design document, and in that document you put two functions, a map function and a reduce function. That's where that map reduce comes in. And I'll explain. I have an example of map reduce in a second. What you do with these, you as the programmer provide the map function and the view function there, and CouchDB takes these, and when you query a view, that's just the basic terminology here, when you query a view, CouchDB executes the functions you provided. You don't actually execute the functions. And then CouchDB runs all the data through the function that returns the calculated result. And here's a simple example of how that works. We have a database and a set of documents in there, and the first step is the map thing. And what map does is it creates a list of keys and values. And in this case, we have like messages, emails, and we tag them. And we want to create a nice tag cloud, and for that we need to know how often a single tag occurred in our data. So what the map thing does, it just runs through all the data, all the documents we have, and just spits out all the tags we have. If a document has multiple tags, it puts multiple entries into the list. And as value, it puts out 1, which is the count of the single occurrence of this tag, which sounds weird at first. It's a bit strange, but that's how MapReduce works, and it becomes clear in a second. So what we have is a list of all tags that occur in our database and all the counts for these single tags. Now, the reduce step, the left list is what we just saw. Reduce step on the reduce function gets for each key, we put out all the values and can then operate on the values that we have in the map list on the left side. So what we just do for the 2 tags that occur twice, we just sum up the values, which ends up being the count. That's why we have that there. Ends up being the count of that tag in our database. And this is a very, very basic example of how to do calculation. You can do really fancy things there to query everything you actually need. Since this is a programmer-centric conference, there's code, and this is the map function. That's just 2.5 lines of code. what happens when you query the view is CouchDB goes through a database and throws each document in the database into the view into the map function. And now it receives a doc argument, which is our document, and this document has an array attribute that is called tags, and we just iterate over that one and emit, that's our internal function to create this list you just saw, with the name of the tags and the count of 1. And that produces the list on the left. Now, the reduce function gets each key and an array of all the values, just like I just explained, and it just loops over the values and sums them up, returns the sum for that key, and we get the right list here. Why do we do that? MapReduce is a concept that is parallelizable. That means each steps in between, and even the mapping and the reducing can happen simultaneously on different machines. So if we have 100 million documents to count the tags and then have 10 machines running on that calculation, that will be faster than on a single machine. And with MapReduce, we can distribute like subsets of the keys and do parts of the calculation on each machine and then combine the result and return it. That is a very powerful mechanism, and that's why Google is so rich. So we thought that's a good idea to implement. 2 more things about views. You probably cringed when I said when you query the view, CouchDB goes through all the documents in a database. It does that once to create an index, and each subsequent request then reads the intermediate result. It gets this request gets cached. And if you change things in a CouchDB database, views don't get changed directly on the document change. You don't pay a view index creation penalty, but the CouchDB index or the view index get rebuilt when you query the view again. So there might be happening a lot of reads and writes and deletes and whatever, and then the views just don't care. And when a view is queried the next time, only the changes that happened in between the last time the view was queried and now get integrated into the index and returned. This makes a view index creation, the view lookups very fast and very efficient. And the internal structure of CouchDB is totally optimized to this quickly recreating or updating the indexes incrementally. So that's a very fast operation here. The other thing, so yeah, views are incremental, built on demand, and the reduce part is optional. So if you just want a list of all the tags, even the duplicates, you'll just leave out the reduce function and get the list that the map function returns. If you want that, that's possible as well. And again, with going back to the HTTP interface, each view has a URI in CouchDB, and you can again do the CRUD operations over HTTP, like with the get post put again there. So they're handled in the same way as documents are handled. So that's again very easy to use from programming perspective. The next thing I'm going to talk about is replication. The basic idea here is it's a good idea to have your data with you. Well, we have internet access everywhere except when we don't, and it doesn't work, or it's slow, or the data you have is just too much data to send over the wire again, or if you want to deliberately be offline, to not be like Twitter disturbed all the time. So you would probably want to have the data with you. And the one scenario there is you work for a big corporation. They have a huge internal customer database and all the associated data in an application. And then you have a copy of that application on your notebook. And you'll be able to replicate the company's database onto your notebook or laptop. Go to the client, that might be Apple, and doesn't allow any GSM or Wi-Fi or internet access there. And you're still able to use the application as if you would use the live database, because you have a real copy of that database to work on. And what replication then allows you when you get back home is to synchronize the changes you made with that master database on your company. And in fact, the company might have a lot of representatives running around, and they all can integrate the changes back to the master database. And all the changes that happen there then can go back to you so that you have the latest data. This is like the one scenario there. The other ones are in a web application. If you have a really cool database and all the nice views and MapReduce and all this, if your hardware goes away for whatever reason, then your application is down, and that just can't be. So you usually have multiple database servers to be safe against hardware failure. You will probably have more database servers if application gets bigger to spread load, read and write load. And replication there helps you to get all the instances of your database up to the same level of data, so that can do like load balancing, failover things, and obviously backup is possible too with that. And the way replication works is not like with the first scenario. There's no constant streaming of changes going on. It's more like an rsync operation where there are two sets of data, and the replication compares or creates a diff, and then just moves over just applies the diff to the other database. So this is has the same data than the other one. And this also, this just not works. It's not only works with two nodes, but with any number of nodes. So, with a MySQL replication, you usually have a master server that all the write requests to, or like a set of master servers, and then another battery of read servers or slaves where all the reads go from. And with the CouchDB, you don't need to set up such a fragile system. You can have any number of master servers and have them replicate back and forth and have them eventually come up with all the same data. And this eventual consistency is a topic that Werner Vogels, the CEO of Amazon, wrote a great paper about. I really encourage you to look into that one. That's the secret behind why Amazon is so massively scalable, that they don't force the upfront consistency that a relational database requires. So, CouchDB there. This paper was published after CouchDB was released, so there's no relation there. But this is a very powerful concept that is used in practice and very successfully. The one problem with distributed replication is if two or more instances of your database get a change for the same document and then want to replicate, that's called a conflict. And obviously, that's a problem situation there. And what CouchDB does is that each node, upon replication, sees that there are so many changes that are in a conflict, and it chooses one of these conflicting versions to be the winner. And each node in this replication environment comes up with the same winner. And they do that on their own. And there's a deterministic algorithm going on that for each node, each node can independently come up with the same winner that everybody else does, without any group communication between the servers. So if there's a network shortage or something, or the network is slow in between, we don't wait for everybody to agree on some winner, but we just pick the same one. And now what happens with the versioning system, that comes in handy there that I explained earlier. Like the winning version gets saved as the latest revision of the document, and all the losing revisions get saved as previous revisions. And the CouchDB then sets a flag at that document and says, okay, here's a conflict, and that needs to be dealt with. And usually the application can decide what to do then. Like there's probably timestamping going on, and you can see there's stale data here, and we just throw that away. Or we see the winner that was chosen is not the data we want to end up with, and we promote one of the losing revisions to be the actual winner and resolve the conflict and have that replicated back through our cluster. Yes, question?
Where, like in one document, one field was changed, another document, different field was changed. Would it match those together, or would one document?
The question is if the replication is on the document level or on the field level. So if there would the change would be in different fields in two documents. Would they be merged, or would there still be a conflict? At the moment, there would still be a conflict. We might go to have like field or row level conflict detection, but that's not in at the moment. So where was I? With the conflicts. All right. So most of the conflicts, or most conflicts, can resolve automatically by the application. The user usually doesn't have to see any of that. But in case the application can decide, your application can show the user, okay, we have these document or this data here. Which one is the one you want to keep, and then resolve the conflict from there. That is, it's a pretty neat way of dealing with this replication problem. And the idea is that your cluster of databases has a consistent view of all your data, so that the application can't ask two servers and get two different answers. There's consistency, eventual consistency again that CouchDB has. Okay, that's replication. The next one is build for the future. The databases we use today were designed and built 20, 30 years ago. And the computing model back then was there's a scientist, has a set of operations to run or calculations to run. He goes to this huge badass machine, sits in front, types in his things, gets a result back, and the machine is built in the way, and the software and the questions or the calculations are built in the way that the answers can come back as fast as possible, so that the next scientist can come in and work on his problems, because both the scientists and these machines are very expensive. This is fundamentally different from how we use computers today. We have lots of machines, lots of different lots of CPUs, lots of cores per CPU. And we have 10,000 users hitting a single server at the same time. There's massive concurrency going on. And this is fundamentally different from how the databases we use today for these systems were designed and built. And I find it really, I don't know, it's a great accomplishment. Well, it's really astounding that these systems actually do work and can handle this load that they were not designed for. It's impressive, I find. And what CouchDB does, it acknowledges that we have this new hardware going on, that we use cheap hardware instead of huge machines, that we have multiple CPUs, that we have a lot of disk space, and that we have more of this concurrent usage model instead of the single and serialized usage model there. Programming is all about trade-offs. CouchDB trades disk space for data consistency, speed, ease of use, and all that. CouchDB is still reasonable with disk space, but that's the trade-off we take, because disks are so cheap these days that we can waste a bit of that to have all the other cool things. So what CouchDB does is, well, like I said, the relational databases are designed to execute the single query as fast as possible, as fast as hardware allows. And there goes a lot of thinking into designing your data model and the queries to get this as fast as possible result. What CouchDB does is it actually has reasonable or pretty good performance for the single query, but the design idea that it is optimized for it, the concurrency, all of your 10,000 users eventually in a reasonable time get a result, and not just 100 per second, but a really massive parallel load can be handled with that database instead of just a couple of hundreds on a big machine. How does CouchDB do that? CouchDB is written in Erlang. Erlang is a very cool programming platform. The language is a bit weird, but it's still nice. And Erlang was written by Ericsson. Ericsson is a telco company, and they have pretty unique, it was developed in the late 80s and early 90s, and they had pretty unique, for the software world, requirements for their software. That is, sorry. they needed to be able to have or to handle a lot of concurrent telephone calls on a single piece of hardware. And in case there was a problem with one of those telephone calls, there might be a bug in the software, and there's, I don't know, a crash going on. This single problem cannot by no means affect any of the other calls that are going on. You cannot just drop the connections there. People will complain. I don't know, that just wouldn't work. It's not a model that is allowed there. And the other thing is you can't, or you shouldn't need to take the machine offline to create or to make a software update. That means with Erlang you can have a machine running and while it runs, update the system, fix a bug. And this sounds a lot like amateur open heart surgery, and it's really scary when you first hear it. But Erlang puts in a few mechanisms to ensure that nobody dies. So this is actually a very cool thing. And this is a bit of number bragging, but it's really impressive. Ericsson sells this AXD301 telco switch, which they guarantee 9 nines of availability, calculated per year. That is 1/30th of a second per year guaranteed availability. Frankly, I don't believe that. I have no idea how they pull that off, but they sell it to you so they can guarantee it. It's really impressive. And they do that with all the cool features of Erlang. How's that programming-wise? In Erlang has this concept of very, very lightweight processors, and these processors are they're magnitudes lighter and smaller and easier than POSIX threads, for example. So on this 5-year-old trusty laptop, Erlang is able to spawn 10 to 15,000 processors per second and dispose them again. So they're very, very, very small. And being a functional programming language, Erlang doesn't maintain a global state for your application. That means that there's one chain of processes can change some shared data that causes another one to crash. That's why thread programming is so hard. That just is not in there. It's not allowed. So it's very very failure resistant. The way it works, because we have these cheap processors, each module that is sort of like a class in Erlang. when you call a function, and there you actually send a message to another process. So all the function calls you do or method calls you do in your application are actually run in different processes inside of Erlang, and you end up with this long call chain of processes. And now, if there's a problem in the current running instance of such a process, what you do usually in Erlang is just terminate this small process and report to the calling process, and it can then decide what to do. And it may decide to crash itself, and you have this crash chain going on up to the original calling code. This greatly simplifies code because you don't handle errors, you just crash. You save like 2/3 of nasty error handling code. You just crash your current chain of processes without affecting any of the other things going on. So there might be a single problem somewhere crashing, and you still can serve the other 9,999 users in parallel that you're doing there. Erlang allows you to do that. I could go on to praise Erlang for like hours. Well, I'll stop here. Go to the other point. The storage model of CouchDB, that is how bits and bytes actually get written to disk, is very, very clever. First, it is ACID compliant. That means basically your data is safe and secure and all that with your database once it says it has written the data. So that's basically one of these basic things a database should do as ACID compliant data. So I won't go into details here. The other thing that makes it so smart is the MVCC, or multi-version concurrency control. That allows, again for the concurrency going on. When when you have a data store and there's a read process and the write process going on at the same time. You don't want the read process to end up with half of the data that came in before, was there before the write, and half of the data that was in after the write. So that would be garbage. You don't want that, obviously. And well, the basic way of doing or dealing with that is saying, okay, when there's a write, we block everybody else who wants to read or write until the write is done, and then we let readers in again. Or if anybody is reading, nobody can write it, as long as there are, at some point there will be, the readers need to be blocked and all that. And with the MVCC storage, and there comes the revisioning system in again. When you read a document in CouchDB, you only ever get to see this, the version that was current at the time you read it. When in the meantime, a new version is appended to the CouchDB database, is added there, the reader just doesn't care about it. It only gets to see the data that was current again when it started reading. It also allows any number of parallel readers onto a database. That means as much as your hardware permits, and everyone gets only the data that was current at the time they were starting to read. The only thing we need to be aware of is that document writes need to be serialized. We can only have one write happen at one time, and yeah, that's like the writes get placed into a queue and worked off. And the possible or potential problem is here that your hardware is not fast enough to deal with all the writes coming in. But that's the point where you need to partition the data out to multiple servers anyway. That's the same thing with any database. If you're like the underlying hardware is just not powerful enough, you just need more need more data there. Now the way these that's a question.
Message queue concurrency to handle things, and you brought that thing you just brought up. What would happen then if the queue did get full? What sort of mechanisms are in place in CouchDB to allow you to handle that, like in a live situation?
What would happen in case the write queue of CouchDB would get full and the hard? I'm kind of trying to think of that. I think what eventually, at some point, RAM would fill with all the write requests that were stored, and the request time for the response time for this write request would just grow. And at the point when there's no more RAM to take in more write requests, the new write requests would just deny it earlier. Sorry?
A lot of badness.
Yeah, a lot of badness. But the way CouchDB is designed is that it gracefully, well, if resources fill up, it gracefully declines accepting more data and these things, and then waits until resources are available again without just crashing the whole database server. So when your application would detect that writes wouldn't get handled in a snap, I would see, okay, and then the application would say, okay, we have a huge server load, we got to wait for a bit here, and show the user probably a waiting, or just a temporary site to say, wait off until all these things can be flushed to disk again. So that would be, you'd be able to monitor that, and then eventually you would need more hardware to deal with your load. Another question.
Create a new node, whatever you're calling it.
Yes.
On the fly, would that be something have people done that? Like, they monitor the activity and then based on, the load, pop up new nodes, things like that?
The question is, have people done actual monitoring of a CouchDB database and then on demand popping up new nodes, handling new, the write load or read load? Not that I'm aware of. This is kind of a management of CouchDB thing. I haven't seen anybody doing that, but that's obviously a way to go. Yes. So, one more thing about the data store: the way the things get committed to disks ensure that after each write of a document, the entire database is in a consistent state. And if during a write your hardware happens to fail or power goes off and anything, your database is still in a consistent state. So when you restart CouchDB, when your hardware is back again, you don't need lengthy integrity checks running that could take hours on a reasonably sized database. CouchDB is up and running in no time again. Data is always consistent on disk, which is pretty neat if you ever deal with the MySQL problem. So I won't get into. I like to talk about the storage engine a lot, like I like to talk about Erlang, but I keep it short in favor of time here. We've got a few bonus features. In the end, actual people would use your application. We people use natural language to communicate. People will put natural language into your application, and they will want to search for that data using natural language search. Or natural language or full text search is not a matter of comparing lists of characters. There's linguistics involved, and it's a very broad field of research and practical things. And instead of doing that ourselves, we just leverage existing technology. And Leucine is a framework to create full text indexes. And what CouchDB does is just implements a full text mechanism that reads CouchDB documents and stores them into a full text index, and then has a mechanism to query this full text index using the Leucine native query syntax. This is set up in a way that if you don't happen to like Leucine or don't happen to like our version of Leucine, which is a Java one, you can plug in any search technology you want, whether it's Sphinx or there's a couple of other ones. On the Mac, there's Spotlight. You will be able to integrate that. So the actual full-text search engine you use is your thing to choose. One thing I forgot about to tell about the views. I said we use JavaScript functions because they are a natural fit for the JSON data we have. You're actually able to change the query language there. So you could write your query, the map reduce functions in Ruby or Python or any other language, and have CouchDB work with that without changing a lot of things if you don't happen to like JavaScript for that structure, for that situation, for your need. Okay. The other thing is JSearch, which is a research project from within IBM that's going to be open sourced. It's basically XPath for JSON, where you can query JSON structures and do nasty things with that. That's not actually in CouchDB at the moment, but this is something we're really keen on getting in. Okay, a little bit of history. Damon Katz, this is the guy who came up with all the cool ideas and most of the implementation. He used to work for Iris, which is a consultancy that created Lotus nodes for Lotus, which then got bought by IBM and is I think a 10 billion per year enterprise for IBM, very successful. And Damien worked on the core database engine of Lotus nodes, which is in concept with the documents and the replication, very similar to what CouchDB has. So there's some leverage of ideas there. Well, Damien at some point said, "Fuck this, we need something better here," and he quit his job, took his wife and his newborn daughter, went to a place near their families where it's cheaper to live, and lived off his savings for 2 full years to create CouchDB and release it as an open source project. I wouldn't have done that, but it's very, very impressive. So, yeah, Damien's an amazing guy. He now works again for IBM. They hired him to work full-time on CouchDB. And this is set up in a way that there are actually no strings attached. We were recently accepted by the Apache Software Foundation to become an Apache project, so we will be Apache CouchDB. And all the code Damien writes for IBM is obviously copyrighted by IBM, but they donate a copyright, royalty-free and worldwide and all that, to the Apache Software Foundation. So in case the IBM loses interest in CouchDB and uses Damien for something else or fires him, all the things he did will still be in the open source project CouchDB. So they didn't bind the software to them. They just hired the developer to work with it. And we release on the Apache 2.0 license now. And again, there are no strings attached. That's a good one. Anyway, I obviously didn't cover everything. I just scratched the surface, and there's a lot of things going on, a lot of things to talk about CouchDB. And I'll be giving 2 CouchDB tutorials, like 3-hour tutorials with programming examples and all that, next month, in May and in June or July, forget, at the XTech conference in Dublin, Ireland, and the Erlang Exchange conference in London. If you happen to be around and be interested or want to come up there, you can read about that on my blog when these things happen, so you could show up there. If you've got any other things you would know, the slides will be online at some point. You just follow these links. Damien's blog, my blog, the official CouchDB things. And the last link is, I gave a presentation at MailTrust 2 weeks ago, and they taped my presentation. They can see me giving the same talk, only over 2 hours with a lot more, with a bit more technical detail, if you like to. You usually do a demo, but time's up now, so I signed up for a lightning talk, and if you want me to, I'll give a short, like, I need to prepare, I couldn't do it now. So I can give a short demo of a CouchDB distributed application in the lightning talks. Yes.
Is there any concept of a transaction?
The question is, does CouchDB have the concept of a transaction? Yes, it has. That is, the first is a document write or update happens or doesn't happen. So there's single entity transaction, and you can do multi-part post requests to send batches of data that succeed or don't succeed. What it doesn't do is like two-phase commit or ensure that a set of changes happen on multiple nodes. You would need to implement that in your application. Also, with the multi-part post request, you can do you can't put in a delete in there, so you will only have write operations. There are no delete operations in that transaction thing going on. This is the questions. Yes.
I was wondering if you could talk about production status and maybe the roadmap for the next few months.
Yeah, questions about production status. CouchDB at the moment, we label it as alpha software, and we mean with alpha that we don't have all the features in that we want to have for 1.0, but there are systems running CouchDB at the moment that don't have any problems. So the features that are in are pretty stable. We just don't have everything to call everything in. We wanted to call it a beta or final release, and we want to have. Now that Damien is back working on it full time, I think during summer we go into beta and then have a release sometime after that. How good, depending how good that goes. Question?
When you insert data, is it appended or is it a whole new entry in the database? And are deletes idiomatic? How do you delete?
Okay, question is if changes to documents get appended inside the database. Yes. So you would, instead of changing actual data on disk, we just append things to the database file.
Is it a whole new record or is it just the diffs?
It is a whole, it isn't the question is if it's a diff or a whole new record. It's a whole new record. We don't store the diffs. At some point, I think we will have the ability that you send in diffs and calculate the new revisions from that, but we don't have that at the moment. The other question is if we do actual deletes with this model. We don't. We just mark as delete. So your database grows all the time, even if you delete data. And there's a process called compaction that runs periodically that gets rid of all the old revisions and deleted data eventually to gain hard disk space back. That is where CouchDB wastes data in favor of speed and consistency. Yeah, sorry, question?
The view implementation, how is it tied to the JSON structure? Is it a one-to-one mapping that says I have to have these fields in order to be able to map to this view? Or is there some kind of typing that says if I see strings, I can put them in?
Okay, the question is how the JSON structure is tied to what you have in the views. When you create the view, the map and reduce functions, you actually can define a JSON object, again, with the fields you want to have eventually in the view. So you say you want a view with all the names and nicknames of all the persons. You would just emit a new JSON object that has the structure you want to with all the data in it, and then when you query the view, you get this predefined object back with the data in it.
If I have to find a view for something, is there any way for me to, is there a way for me to, or do I have to define a view in order to see data?
Oh, do you have to define a view in order to see data? Not if you, obviously not if you request single documents, but if you want to have ranges of documents, you create a view. If you're familiar with relational databases, think of a view as index on a column. Have as many views as you want for all the data you need to get out. Okay, that was another question?
Specifically for Ruby, I've kind of looked at the API. It seems pretty straightforward how to use it. The only part I can't quite figure out is how you register the mapping and using functions with the database.
Okay, the question is how to actually create a view, how do you put in the map and reduce functions into CouchDB. We have this thing we call design documents that are just documents that have a special URL that then CouchDB recognizes to be a view definition document, and you put the literal code, the JavaScript code for those functions into this document, and they have to have a certain structure for that. And you can find examples on the CouchDBwiki.com. And then CouchDB sees that as a view and reads this document and applies these functions from there. The question over there, yes?
Okay, the whole thing about RDBMS versus just storing data. Is it reasonable to see CouchDB as an object database that just happens to use JSON?
The question is if CouchDB is just an object database that happens to use JSON. I must admit I'm not too familiar with what is called object or object-oriented databases. We obviously don't have all the full-fledged features that OO features. We just store objects into CouchDB, so I don't know. Well, what we call, Damien called CouchDB document-based or document database, so that's a bit different there.
Why? Like, what's the? Why do you use a document database instead of RDBMS?
Okay, why would you want to use a document database instead of an RDBMS? I should say, CouchDB is not meant as like a silver bullet thing that solves all your problems. There are situations where a relational database is just the perfect fit because the model of your data just naturally fits this relational data. But it happens to be that most data we use in the real world is not relational, and there's an artificial thing going on to transform that to fit on that relational model, and you can then probably decide if that model fits your data. The most of the data we use, like the business card receipts example, that's all the data we use in the real world, and there's no, like on my business card is no pointer to the actual data that gets updated when I change my address. Well, it is printed on the thing and can get outdated, and people might end up with old revisions of my business card that are no longer valid, and somehow we can deal with that as people. So this concept is just applied to the database store. Okay. More questions? Yes, please.
I have a question on replication. Does each database have to have the full data? So like in your example of in a business, then you can have a client application that has all the data. What if you have data in your database that shouldn't be accessible to all users?
Question about replication, if all the nodes must have all the data. At the moment, yes, but you will be able to define replication on a view level. So you would say, I would be able to say, replicate only the data that is in this view or the documents that match this view, so that you can send only a subset of the data to a replicating database. Also, security, I didn't talk about that, will be implemented in that way that you have a mechanism to say this set of documents is not allowed to be read or read by this sort of users. Again, that's not in at the moment, but that's how it's going to work. Got a question?
What was his question? Must each database have the full data?
Yeah, all must be. If you have
my question would be like when, like at what point? That just
Yeah, if you have a company internal application and then you have a client application, and the client application obviously shouldn't have all the data from the company application, but just a subset of that. So if you have like a database with confidential information and only want to have a subset of that for the client, so would it be able to just replicate a subset? I think that was your question. Yeah.
I was wondering, could you touch on security?
No. The question is if I can touch on security. I would love to, but there's no built-in security in CouchDB at the moment. We will have a full-fledged security and authentication system where documents have users and you can validate documents on write, so you have certain ways to enforce some sort of structure, and documents that don't match that will get rejected for writes. I will read and write permissions and all that. Well, that's at the moment not in. So you would, if you would run CouchDB, it would be behind some sort of proxy layer thing that is not actually exposed to a user. Yes?
Are the views intended to be used across a homogeneous data set, or can they be a different schema?
The question is if CouchDB views can be used or should be used, can or should?
Is there an assumption that every object is the same?
Okay, for a document, do all documents need to be the same to be in the same view? No. This is, you can, like, for example, you have an address book application and you decide to have a name field and all the other fields. And at some point you want to split it into first name and last name. So you have an old document set that has just a name field, and your application would read a view that has a name field, and now the new database of the new documents have a field in first name and last name field. In the view, what you could do is, for this object that you store in the view, you could concatenate the first and the last name and return that as the name so that your application can still use it. So views are one way to aggregate this semi-structured data. Yes?
Are there plans to include something similar to SQL triggers in future releases?
The question is if there are plans to add something like triggers in SQL databases. We have that. There is a mechanism in CouchDB that you can register a standalone daemon that you would need to write that gets an update notification each time a database gets changed. And that's actually the way full-text indexing works already. So you could get notification each time there's a change in your database and then act on that notification. That already works. Good. Another question.
Any plans for like integrating it with the browser, like Google Gears? Or is the preferred model for the clients like that?
The question is if there's any plans to integrate it with a browser like Google Gears. We are not the ones to talk to that. That would be the browser vendors, or that would be a perfect usage model for CouchDB. Integration with client, I will show that in the demo, since it's an HTTP API and you can put HTML documents inside CouchDB document attachments that have a unique URI. You can query this attachment inside a browser, have a web page rendered there, and then have AJAX calls talk to CouchDB, so you can have a full-fledged application served and running from CouchDB without any middleware. So there's another usage model there, which obviously you don't want to do in without the security stuff going on. But for internal applications, well, this is already possible. And CouchDB comes with a administration program that works that way. That's just a jQuery Ajax website thing where you can administer your CouchDB. Another question.
I had a follow-up question. What if it's not business cards you're just storing? What if it's different types of data? Do you tell the data types? Do you determine the data types from the URI?
The question is if I happen to have multiple data types, not only business cards. There's no way to force you to do that. Each document can have a different structure, and there's no way to tell up front unless you query the query for the document. we are still developing best practices working with CouchDB. One thing would be have a type field that would tell your application which type of document you put in there, and if it's a business card, have all these in a view that lists all the people, and if it happens to be, I don't know, inventory or just all computers in the company, there would be a different type. So you could do that, or you could query on the structure of a document. So if you know I don't know, if there's a field person or a key person in this document, then you know it is a business card entry, and if there's a field inventory, regardless of its data, you could do queries on the structure of your documents to determine which type it is. Well, it doesn't enforce it, but obviously you would want to have some sort of mechanism there. The one thing is we will have validation functions. They were just functions you provide, like with the MapReduce functions, and that will be applied on write. And so if you would, and it could check if you write this document and it doesn't, the validation function doesn't return true, so it can check for certain structure, for certain things to be there. If it doesn't allow the actual write to happen, the write gets rejected to the user, so you can enforce some schema there if you want to, but you don't have to. Also, that's not in at the moment, but we will have that. Good. Yes, another question?
Time frame for 1.0.
This is a time frame for 1.0. Like I said, we hope to have a beta going on in summer, and then depending on how things go, have a 1.0 sometime after that. Okay. If you've got any other question, want to ask later, that pop up later, just grab me in the hallway or anywhere. Send me an email, I don't know, just talk to me, I'm here. Thanks.